This is Darrell presenting Apple's Develop in Swift Fundamentals course, Unit 2, Lesson 4, Classes and Inheritance. Today we're going to learn that classes and structures are very similar. The main differences are inheritance and value versus reference types. Here's an example of a class implementation. It looks almost identical to a struct implementation. The keyword that starts it is class instead of struct, but a class also has properties, it has initializers, and it has methods. We can use the initializer to create a person. The type are normally we name a type in upper camel case or capitalized, and then an instance of the type would be in lower camel case, or starting with a lower case. And then we can once we initialize it, we can print out the properties, and we can execute the methods of our instance. Classes can have inheritance. We can have base classes, which are classes that do not have a superclass, and then we can create a subclass of a base class. And if you create a subclass of a base class, then the parent class is a superclass. As an example, we could have vehicle as a base class, and then bicycle could be a subclass of vehicle, and then tandem bicycle could be a subclass of bicycle. And then if tandem bicycle was a subclass of bicycle, then bicycle would be a superclass of tandem bicycle. Here we've defined a base class vehicle. It does not inherit from any other class, so it is a base class. It has a property current speed with a default value of 0. We have a description, which is a computed property, which returns a type string. And then we have the implementation of the computed property. Because the computed property is only one line, we do not need the return keyword. We have a instant method, make noise, and we do not have an implementation of make noise for the base class. And then we could instantiate a instance of the vehicle, and then we could print out the vehicle's description. Here is the syntax for creating a subclass. You have your class, your new class name, a colon, and then you have the superclass that you're inheriting behavior from, and then you have your implementation for the subclass. In our case, bicycle is a subclass of vehicle, and we are inheriting most of the behavior from vehicle, but we're adding a new instance property, has basket, with a default value of false. Here's an example of us using our subclass. We create a instance of bicycle, and note that we're using the let keyword here. We're creating a constant bicycle. Classes are passed by reference. So when we create this bicycle and it's a constant, that means that this variable bicycle this memory bicycle always points to this specific bicycle. However, we can still change the value of the properties inside bicycle, and we're going to talk about that more. However, in this case, we create our bicycle, we set has basket to be equal to true, and we can set the current speed to be 15, and then we can print out the description. Now, when we set the has basket, that was a property in the bicycle subclass. However, when we set the current speed, that was a property in the vehicle superclass, and the description was a method in the vehicle superclass. Here we're creating a further subclass. Tandem is a subclass of bicycle, and we already know that bicycle is a subclass of vehicle. And for tandem, we've added a new property, current number of passengers. It is of type integer, and we set a default value of 0. Now you'll notice we have not been creating any initializers for our classes. In these classes, we've set default values on every property, and as a result, we get an empty init. However, if we did not have default values, then we would have been forced to create an initializer. Classes do not get a free member-wise, an automatically generated member-wise initializer like structs. The one exception is if the class has all of its values have a default, all of its properties have a default value, then it gets an empty initializer. Classes also have the opportunity to have a dinit function, which is automatically called when the class is destroyed because it is no longer referenced by any memory. Here we create an instance of our new subclass tandem, and because every property had a default value, we did not need to create an initializer in our class, and every property was created with the default values. And then this example shows we went ahead and set the values on each of our properties. Has basket, which was in a property of bicycle, current number of passengers, which is a property in the tandem, and current speed, which is a property of the vehicle. And then we were able to print out tandem.description. Tandem.description is a computed property on the vehicle class. Here we create train, which is a subclass of vehicle. We override the vehicle function make noise with our own implementation. When we do that, we must include the override keyword. Otherwise, the compiler would complain because it would think we are accidentally overriding something and it doesn't want us to do it unintentionally. This is an example of how Swift tries to keep us safe by preventing us from accidentally overriding a function. Here's an example where the subclass car is a subclass of vehicle, and we are overriding the computed property description with a different description. And in fact, we're using the super keyword, so we get the description from vehicle, and then we add in gear and then our gear to it. Here we create an instance of car, and then we modify some properties, and then we print out the description, and you can see that we get the traveling at 25 miles per hour, which is from the vehicle description or super.description, and then we added in gear 3. Here we have our person class, which has one property and one initializer, which sets that property. We create a subclass. The subclass adds a new property. However, the new property, we don't have an initializer for it, so because we have a property and it does not have a default value, we must have an initializer for it. We do not automatically get a member-wise initializer in a class. Here's our fix. We have our new initializer for our student subclass. We pass in both properties. We set the property on the subclass, and then we execute the initializer for the superclass using the super keyword. Classes are a reference type. When you create an instance of a class, Swift returns the address of the instance and puts that in the variable. If you assign that address, if you assign the class variable to another variable, then each variable contains the same address. So if you update one instance, all variables refer to the updated instance. So let's look at an example. Here we have a person class with a couple properties. We create a person named Jack, age 24, and then we create a my friend variable, and we assign Jack to it. When we do that, my friend has the same address as Jack. So if I increment the age in Jack, then print out both ages, both of them were incremented because there is only one object at the end. We only created one object. We just have two variables pointing to the same object. Here is the same code, the same data structure implemented as a structure. So we create a structure person named Jack who is age 24, and then when we copy Jack into my friend, structs are passed by value. So a copy of the structure is made, and my friend has a copy of the structure. Then if I increment in Jack, that increases the age on Jack, but it does not increase the age on my friend because my friend is a copy of the entire structure, not just the address of the structure. So Jack becomes 25 and my friend is still only 24. Structs get automatic member-wise initializers if you did not create an initializer of your own. Classes are different. Swift does not create member-wise initializers for classes. The only exception is you do get an empty init if the class has default values for all properties and you don't write any other inits. The common practice is for developers to create their own initializers for their defined classes. So should you use a class or a structure when you're defining your own data structure? Well, we recommend using structures by default. Only use a class if you have to. So use a class when you're working with a framework that uses classes, because then you don't have a choice. Or when you want to refer to the same instance of a type in multiple places, or when you want to model inheritance. If you're following the Apple curriculum, now you can open up the classes playground and complete those exercises. As always, this slide deck is thanks to Apple Computer and is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike International License.